Hi, everybody. Welcome back for day 2 of negative exponents. We are just going to do some practice with these today. There isn't anything new. You're just going to notice that some of these problems have more steps, more operations, and so it's really important that you take these and you work them out step by step, just as I am, so that when you are doing these on your own, you know the correct process and you're not skipping steps and making mistakes. Having said that, there are multiple ways to do each of these problems. So if you're thinking in your head you would have tackled this a completely different way, it's likely that you would have been okay and you would have gotten the same answer. So just know that as we're going through, there are definitely different ways to do the problem. And some of them might be easier than what I thought of. Okay, so if we were in the classroom, we would have had these discussions, but we're just going to have to go with my way for today. So starting with number 1, when I see this, the first thing I think of is, okay, I really want to take care of those double exponents that I see here. So I have a 3m squared to the 4th power. I'm going to take care of that first. So when I do this, I have to take 3 and raise it to the 4th power. So 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So this first monomial is going to be 81, and then I would get m to the 8th, because remember we multiply our exponents. My next step is going to be to take this monomial and raise it to the negative 2nd power. So remember, anytime you have a monomial that's raised to a negative exponent, you want to start by rewriting it as 1 over that monomial, but now to the positive outside exponent. And just to make this look a little nicer, I'm going to make that first monomial a fraction also. I'm going to put it over 1. Okay, so now what I would do is I would go ahead and multiply. So on the top, I'm going to get 81m to the 8th. And then on the bottom, if I go ahead and actually square that monomial, I'm going to get 9m squared n to the 6th. Okay, so I'm almost done. My last step is going to be to divide. So 81 divided by 9 is 9. M to the 8th divided by m squared would be m to the 6th. And then if you think about this as this n to the 6th already being in the denominator, we would have to keep it there. Another way you might think of this is that there might be like an n to the 0 in the numerator. So 0 minus 6 would give you n to the negative 6, which would go to the bottom anyways to become positive. So I like to just think, all right, it's already in the denominator. I need to keep it there. And that's your final answer for that one. Now something like number 2, I don't think we've seen yet, where you have this monomial, but the monomial is actually something that can be divided to the negative exponent. So what I would do with this is I would treat it like order of operations, and I would divide what is in that parentheses first before I raise it to the negative 1st power. So 28 divided by 7 is 4. C squared divided by C, which is really C to the 1st, is C to the 1st. And then D to the 1st divided by D to the 1st is D to the 0, which is just 1, so we don't even write it. And that whole thing is to the negative 1st. So now that you have a single term inside your parentheses, now I would rewrite it. So this would become 1 over 4c to the positive 1st, which we know, sorry guys, is just 1 over 4c. Okay. For number 3, I would do something similar where I would go ahead and try and divide what's in your parentheses first. So when I divide 2 by 3, I'm just going to leave that 2/3. And then x to the negative 14th divided by x to the negative 5th. I'm going to write this out here. Negative 14 minus negative 5 is really negative 9. So this would be x to the negative 9th. And then y to the 12th divided by y to the 8th is y to the 4th. And this whole thing is still to the negative 3rd. Okay, What I would recommend doing from here is cleaning up the inside of your parentheses. And what I mean by that is, let's rewrite it so it's a single fraction, putting the y to the fourth on the top with the 2, and the x to the negative ninth would go to the bottom with the 3 and become positive. So I would have 2y to the fourth over 3x to the ninth, and all of that is to the negative third. Okay, so here's where things get a little crazy. We are going to have to write this whole thing as a fraction to get rid of that negative 3 exponent. So your next step is going to be to do 1 over 2y to the fourth, 3x to the ninth, to the positive third power. Okay, I'm going to start going back up here now. So what that looks like is 1 over, now 2/3 to the third power. I do 2 to the third power, which is 8, and 3 to the third power, which is 27. Y to the fourth to the third power is y to the 12th, and x to the ninth to the third power is x to the 27th. Okay, so we're almost there. The problem is that I can't be done because I have a complex fraction. So we saw this, I think, one time in the previous lesson. Remember, a complex fraction is just dividing. So this is really 1 divided by 8y to the 12th over 27x to the 27th, which I know that in order to divide by a fraction, I have to multiply by its reciprocal. So it really turns into that. And 1 times anything is just whatever I am multiplying by. So my answer is this. Okay, so yes, it's complicated, but again, if you take it step by step, it's definitely manageable. All things that you've done before. Okay, let's look at number 4. So what I would do here is I would start by multiplying what you have in the numerator and then multiplying what you have in the denominator. So if we do that, negative 8 times negative 6 is positive 48. X to the 6th times x to the negative 10th is x to the negative 4th. And y to the negative 3rd times y to the 1st is y to the negative 2nd. And then on the bottom, 3 times negative 4 is negative 12. X to the negative 2 times x to the 1st is x to the negative 1st. And then there is no y to multiply by, so I'm going to leave that y to the negative 5th. At this point, I would go ahead and divide. So 48 divided by negative 12 is negative 4. X to the negative 4th divided by x to the negative 1. Remember, we're subtracting our exponents here. So I'm going to write this out. Negative 4 minus negative 1 is x to the negative 3. And then y to the negative 2 divided by y to the negative 5. So negative 2 minus negative 5 is y to the 3rd. Okay, so just be really careful when you're dividing and subtracting your exponents when they're negative. Now our last step is really just to rewrite this so that we don't have any negative exponents. So remember that coefficient of negative 4, it has an exponent of positive 1. So it's going to stay in the numerator of our fraction, along with the y to the 3rd, because that's a positive exponent. Our x to the negative 3rd is going to go to the denominator and become positive. So that is my answer. Okay. Let's check out number 5. So with this one, again, I would try and divide what you have in the parentheses to start. So 3 divided by 5, I'm just going to leave as 3/5. And then I have x to the 7th divided by x to the 5th is x squared. Y to the 9th divided by y squared is y to the 7th. And all of that is to the negative 3rd power. Okay, so now I have to rewrite this as 1 over this entire everything to the positive third power. Okay, so now what I'm going to do is I'm going to actually do that to the third power. So 3 to the third power, 3 times 3 times 3, is 27. And I would have 5 to the third power, 5 times 5 times 5 is 125. And then x squared to the third power is x to the 6th. And y to the 7th to the third power is y to the 21st. Now we can see that we have a complex fraction here. And so in order to simplify it, remember we multiply by the reciprocal. So what I'm going to show you guys, I think this is going to make this a little clearer. This x to the 6th and y to the 21st belongs on the top with the 27, right? Because they're all positive exponents. So when you go to do your keep, change, flip step, it's important to know where those guys go, because if you go to flip your fraction and you're not sure if it goes with the 27 or the 125, it gets a little confusing. So I'm just going to write this out. Remember, this really means 1 divided by 27x to the 6th, y to the 24th over 125, which then we multiply by the reciprocal. Okay, which just equals that. So my final answer is 125 over 27, x to the 6th, y to the 21st. Okay, so again, if you weren't sure at this step where those x and y went, it would be confusing when you did your keep, change, flip step. So it's good to write it like that. All right, I hope you guys are hanging in there. So with number 6, I am going to start by rewriting both of those monomials as fractions. So I'm going to start by doing 1 over negative 2a squared b to the 3rd, and then that becomes positive 2, times 1 over a to the 5th, b to the 4th to the positive 3rd. Okay, so now I can go ahead and actually evaluate those denominators. So negative 2 squared is 4. A squared to the 2nd power is a to the 4th. And b to the 3rd power squared is b to the 6th. Times 1 over, this would give me a to the 15th and b to the 12th. And now I'm ready to multiply. So on the top, 1 times 1 is 1. On the bottom, 4 times 1 is 4, and then a to the 4th times a to the 15th is a to the 19th, and b to the 6th times b to the 12th is b to the 18th. And I'm done. All right, next one. This one looks like a piece of cake. Let's see. 40 divided by negative 2 is negative 20. And when I divide, I'm subtracting my exponents, so 5 minus negative 2 is going to give me a to the 7th. And I'm done. One step, we like those. Number 8 we saw in the previous lesson, so remember if there's a negative exponent in the denominator, all we need to do is bring it to the numerator, and it becomes the opposite sign. So the answer there would just be x to the 5th. All right, let's get some lengthier ones again. So number 9, we have quite a few things going on here. I would recommend taking care of those powers first. So ab to the 4th cubed, that's going to turn into a to the 3rd, b to the 12th. And then I'm going to square this 5a squared b. That would give me 25 a to the 4th, b squared. And then I'm just going to leave my denominator as it is. So now what you're going to want to do is go ahead and multiply your numerator. So 25 is my coefficient. I would get a to the 7th and b to the 14th. And then my denominator is just going to stay as it is for a minute. Now what I would do is go ahead and divide. So when you divide this, you're going to get 25, and then a to the negative 2. Oh, my cat is stepping on the screen. That's not good. A to the negative 2 and b to the positive 2, which we would then, as our final step, have to rewrite 25b squared over a squared. Okay. All right, number 10. I would start by multiplying what's in the numerator and multiplying what's in the denominator. So we're going to have 24 x to the 9th, y to the 12th in the numerator. And in the denominator, 8x to the 10th, y to the 6th. Now you can go ahead and divide. So 3x to the negative 1st, y to the 6th. And then your last step is to rewrite 3y to the 6th, and then x to the 1st goes to the bottom, and that's it. Okay, so hopefully you're seeing just, working step by step makes it a lot more manageable. All right, so we're almost there. Number 11. Let's go ahead and start by simplifying that power that we have, that 2x to the 4th, y to the 3rd squared. So I'm going to do a little rewriting here. Bring down your 3xy. When I square that monomial, I'm going to get 4x to the 8th, y to the 6th. And then we can, while we're doing this, why don't we go ahead and multiply the two monomials in the denominator. So 12 times 1/2 is 6, and then we would get x to the 11th and y to the 8th. All right, then we can go ahead and multiply the numerators. So I'm going to get 12x to the 9th, y to the 7th, and I'm just going to bring over what I just got in the denominator. Okay, and then I'm ready to divide. So when I do that, I'm going to write this over here. I get 2x to the negative 2, y to the negative 1st. And so my last step is going to be just to rewrite that. Remember that 2, that coefficient, has a positive exponent, so it stays at the top, and the other 2 go to the bottom and become positive. Okay, awesome job. Last one. So here we're dividing negative 4 minus negative 6. Remember, we subtract our exponents when we divide. Gives me r squared. Done and done. Nice job.